Hello, everybody. My name is Alan, and I am a final year PhD candidate at the University of York. And on this talk, I'll be covering How Could They Win, which is an exploration of win condition for esports narratives. Now, because we're talking about esports, I also want to spend some time explaining why we're talking about esports. So, esports is a really big market and it's growing fast. It has vast financial interest, but it also has vast academic interest. And in particular, I want to draw your attention to the machine learning and AI literature, where one particular field is really predominant in this domain, which is the win prediction field. It is so well studied and so well understood that in fact it has bridged the gap from academia to industry. And nowadays most games, so for example Dota 2, which is the esports of choice for this paper, already has a win prediction graph built into the game. So here's an example of the win prediction graph. So anyone watching the game in Dota can open this graph and have a look. And what this graph shows is a prediction of who will win based on the current game state. So at every timestamp, as you can see at the bottom here, we have the time of the match, the current state in which the game is. It's passed through some form of machine learning model, which then produces, well, team one is some amount more likely to win than team two. On this case, we actually have team two right at the end is 65% more likely to win than team one. So that's how you'd read the graph, and that actually draws me to a couple of dilemmas that are known regarding win prediction. So the first one is what's called the accuracy dilemma, where we say a win prediction graph or win prediction model that is too inaccurate, that's not very good at predicting the future, predicting who will win, will obviously not be very good at doing its job, so it's not very accurate. However, a win prediction model that is too accurate is also going to detract from the audience experience, because as we know from the way in which audiences consume esports, a lot of the positive experiences comes from the suspense, comes from the emotional arousal of the narrative, of not knowing what happens next. So if you have a win prediction model that can always know exactly who will win and it's always right, that will damage the way in which audiences consume esports. So it will be a negative impact to the audience experience. So that's sort of where the dilemma is of getting a model that's just right, that will assist with the experience, but also not detract from it. The other one is actually to do with usability. Which is to do with the way in which these models are presented and utilized or not utilized, more accurately. So when you present a win prediction model, you would typically assume that is a forward-facing model, meaning it is predicting the future. But this is not actually the case with these models, because they constantly update. They are constantly looking at the current game state, and as we can see from this example, the game state sort of shifts rapidly. We start predicting the team one will win, which is why the graph is at the top half. But then something happens around this point, and now we're predicting team two will win. So the graph, the model, the prediction updates to reflect the current game state, which means that is the prediction at this time right or wrong? Is this one right or wrong? We don't know. We kind of have to wait for more of the game to play out so we can have a more accurate prediction, which means that this model is actually backwards facing. It uses the previous and the current game state to predict right now. So more accurately, what these models do is to give a summary of the current game state, of saying right now who is winning, which is exactly what the broadcaster, the commentator, is doing. And what's interesting about that is we actually looked at the way in which commentators use these models, and we found they don't. And in fact, we performed a qualitative content analysis to identify how narratives are built. What are the features used in narratives? And we found there are some very clear narrative features that are constantly used. So we designed a different variation of win prediction, which we called win condition. which takes the typical win prediction, which is a function of the current game state to predict the winner, and we flipped it around, and we now present it as a function of the winner to predict the game state. So to explain this in a more visual way, we have a graph, a diagram at the bottom here. So in a typical win prediction, data will flow from left to right, from the state of the game to the winner, through some form of machine learning at the middle. In a win condition model, which is what we're proposing, data will flow backwards. It will flow from the winner to the game state. So from right to left, as opposed to left to right on this diagram. So then the question is, how do we define state? What is state? And this is where our qualitative content analysis comes in, where we found the features that are predominantly used by broadcasters already in narrative. So we can represent state in a way that's actually meaningful to them, that they already use, so they can use this model to build narratives. And here is diagram of the win condition system. So we have lineup and win a star as our starting point on the left. Both of these features go through neural network 1, which then predicts the final duration of the game. So at what time will the game end? These three features then go through neural network 2, which then predicts the final kills. How many kills would that be in the game? And then combine these four features give us the state given the winner. Which actually leads me to what winner star is. Winner star is an exploration variable. So we run the system, for example, twice. Once for team 1 will win, and once for team 2 will win. And we'll have two separate states. They're independent, one for each team. And then we can present that to broadcasters, for example. So this is an example of a very simple way where we can present textually. We have two predictions, or two sort of outputs. One for team 1 is predicted to win at approximately 20 minutes with that many kills, and then one completely independent from the first one is team 2 will win at that time with that many kills. This is sort of like a simple way. There's a more complex way where we do more visual. We run neural network 2 multiple times to predict the scores at different timestamps, and then we outline what neural network 1 predicts, so a predicted duration. And of course, we do that for both teams. And we produce two graphs there, again, read independently. And then very quickly, just our continued work is we're going to do some user evaluation with audiences and commentators to iteratively design this visualization system to improve on the way that we present it, and actually implement that in tournaments to then evaluate again the impact on audience experience. This is the literature that I used on this talk. I preserved the numbering from the paper. Thank you for your time.